Yes, good afternoon to all. Am I audible? Oh, all are in waiting list. Sure. Fine. Yes, good afternoon to all. Am I audible?
Yes, sir.
Yes, sir.
So in the last class, what all we have studied? We have studied the kinematics of the particles. But can anybody tell me what is kinematics? What is kinematics? It is a study of the body when the body is under motion, with considering the forces, effect of the force, or without considering the effect of the force. With or without. What is kinematics? Yes, anybody tell me. See, we have studied equation of motions. Whether have I considered the motion, matlab the force which is required for the motion? नहीं किया ना, फिर it is kinematics whatever we have studied. Yes, all of you. In the see, some people don't know where we are. Is it visible? Everyone? Yes, someone please respond.
Yes, sir.
PPT, is it visible?
Yes, sir.
Okay, fine. Okay. So the after CGMI, center of gravity and all, we have started the section 2, correct? This is up to section center CG and MI, it is section 1. This entire parts come under statics, correct? And now whatever we are studying from the chapter number 5 and 6, 5, 6, 7, 8, it is in dynamics. Dynamics, correct? So then we have studied the chapter number 5. So what is that? Kinematics of the particles. What is kinematics of particles? Can anybody tell me? Online people. Online people. Can anybody tell me what is kinematics? Yes. Anybody? Anyone? Roll number 3, 4, 5. Roll number 30. Vikram, Vivek.
It is dynamics which deals with motion of body.
Yes. Motion of the body. Next, it is incomplete.
Without considering the forces causing the motion of the body.
Yes, very good. It is the study of the particle when the particle is under motion without considering the effect of the forces. Okay, that is in kinematics. What is kinetics? Yes, can anybody tell me what is kinetics?
Forces and the effect of the body in motion by considering mass and forces causing motion.
Yes, very good. So by considering the mass and mass of the body, okay, in motion. See, this is the chapter number 6. Chapter number 6, and what we are studying? This is the first one. Newton's laws of motion for the linear motion and angular motion. Next, D'Alembert's principle. Rectilinear motion on a rough inclined plane. Motion of a lift. Motion of a connected bodies. Okay. Then in circular motion, kinetics of the kinetics of rotation, torque, mass moment of inertia, problems on the centroidal rotation. Okay. So don't worry, what is important that we will study here. Okay. So first of all, you have studied in the first chapter only. What is mechanics? It is a branch of physical science or physics which deals with the study of the forces and their effect acting on the body, which is in at rest or in motion. Correct? That is called as mechanics. Then this mechanics again it is considered as engineering mechanics that deals with the study of the different laws and principles of mechanics applied to solve the engineering problems. That is called as engineering mechanics. Then this engineering mechanics is broadly divided into two parts. One is statics and one more is dynamics. So static is a branch of engineering mechanics, which deals with the study of forces and their effects acting on the body, which is at rest. This is important. In the static, the body is at rest in condition. Then next one is dynamics. Dynamics is it is a branch of engineering mechanics which deals with the study of forces and their effect acting on the body which is in motion. Again, this dynamics is classified into two parts. One is kinetics and one more is kinematics. Okay, you are not supposed to forget this one. Okay, so even though you are in a sleeping mode, then also you have to call me. Then also you have to recall. Okay, these words. Okay, that is statics or dynamics. Okay, in the dynamics again there is a two parts. First one is kinetics and second one is kinematics. Okay, what is kinetics? What we have studied? We have studied this kinematics. Okay, kinematics is a branch of dynamics. A statement I say लिखने का, then it is, sounds good. Okay, which deals with the study of forces and their effect acting on the body, which is under motion, which is in motion, without considering the mass of the body and the forces which cause the motion. Okay, whatever we have done the till now equation of the projectile and again equation of the motion. Okay, in the curvilinear motion, have I considered any mass of the body? No, I have not considered. Just whether the body is under motion or not, only I have considered. Okay, I have studied the particle behavior in motion without considering the mass or the force which is causing the motion. I have not considered. That is called kinematics. We have studied in detail. Okay, now we will move on to the kinetics part. What is kinetics? It is a branch of dynamics which deals with the study of forces and their effect acting on the body in motion by considering the mass of the body and forces which cause the motion. Okay, so whatever the body is moving from one point to another point, why it is moving? There may be some force which is acting on the body, and we have to consider that force and also by considering the mass of the body. Okay, by considering these two, we have to solve the problems. That part is called as kinetics. Is it clear, everyone?
Yes, sir.
Yes. So you know, you all studied that what is Newton's laws of motion. Yes. Can anybody tell me what is Newton's first law?
Everybody tends to be its original position, whether it is in motion or static.
Yes. Everybody stays in a state of rest or motion. Okay. Until and unless the force is external force is applied on the body.
External unbalanced force.
So every body continues in its state of rest or of uniform motion in a straight line. Okay, if the body is in the rest position, it will be rest only whenever you come and see. Okay, if at all, see in the solar planet, the whatever satellites you are seeing, okay, all the planets, they are under motion, correct? Okay, they will be always under. If you see today, tomorrow, day after tomorrow, they will be under uniform motion only. Okay, uniform motion in a straight line unless it is acted by an external unbalanced force. If at all any external unbalanced force is acting, then its position is going to change, or else it's a state of that is a uniform motion or uniform rest is under same only. Okay.
नहीं तो इसका मतलब ये होगा कि दोनों तरफ
balance. If you are not mentioning a unbalanced means if you are applying F force here, if you apply the same F force in the opposite direction, then there is no motion. Correct na? That's why there should be unbalanced. Is it clear, everyone? Yes, all of you. Is it clear?
Yes.
Yes, sir.
Yes. Then
Yes, sir.
see this body is it will be under motion only. It will not change at all. Okay, first one, because there is no external force. So this body is also at a rest only, because there is a force, external force, but the same external force is there. There is no unbalanced force. The force is balanced. It is also in static. Okay, or first law of motion. Here they go. There is a unbalanced force. Okay, only one side force. It means this position is going to change. Here it is in rest position. Okay, here there is an unbalanced force is given. Okay, it is going to change. Now it is in motion. It will be motion only. Then there is an external force. Okay, a ball is coming and hitting the net. Okay, the net is offering resistance force. Then it is going to change its motion.
अब यहाँ पर हमने फुटबॉल लिया तो फिर उसका हम सिर्फ उसका एयर टाइम इसलिए पकड़ेंगे कि वो जब जाकर रुकेगा वो भी हमें काउंट करना है उसमें
No, no.
क्योंकि वो हर वक्त उसकी स्पीड धीमी होती जाएगी ना
हाँ।
कम होती जाएगी
हाँ।
तो फिर वो कंटिन्यू वो स्टेट उसमें
See, when it is in rest position, at that time you can apply the Newton's first law. So there is no any force. If you give the force, then it is position is going to change. Then Newton's first law is not applicable. Okay. Just इसमें क्या है? When the body is in static and when the body is under motion. वो example. Then you have studied Newton's second law of motion. Correct? So that is rate of change of momentum is directly proportional to the applied force. That can also be written as the change takes place in the direction of the applied force. Okay. So what is momentum? What
F
is
into-
momentum? Yes.
F into D.
F into D. No, I am
Yeah,
asking
we-
moment. I'm not asking moment. I am not asking moment. I'm not asking moment. I'm asking momentum. Yes, yes, yes. Correct. One answer I got. Momentum. What is that?
Velocity.
Yes. Mass into velocity. Correct. Mass into a large force or force into velocity. Okay. A large force is acting in a small. No. What is it? Mass into velocity. Kg meter per second. Okay. Momentum. Okay. You will study again. See again, according to the Newton's law of motion, it is a F is equal to m into a, and you have studied all these things. Okay, now we are coming to the D'Alembert's principle. Okay, before coming to the D'Alembert's principle, just write down on some statements. All of you write down. अभी मैं डिटेल करते ना. Write down. Unit number 6. Unit number 6. Kinetics of particles. Okay. After writing the projectile, और एक problem मैंने homework देने वाला है. Leave 2 pages, front and back. Okay. After completing previous problem, leave 1 page, front and back. Okay. Then write down this unit number 6. I will give one more problem there. Yes, all of you. Are you getting my point? सभी को मेरा point है? अभी प्रोजेक्टाइल का प्रॉब्लम लिखा है ना, उसके बाद 2 पेज छोड़िए, फ्रंट एंड बैक. ओके, नेक्स्ट पेज में लिखिए. नहीं, ओके, दिस इज स्टार्टिंग पॉइंट. वॉट एवर पीपीटी इज देयर, दैट पीपीटी, बट आई एम डिक्टेटिंग. काइनेटिक्स ऑफ पार्टिकल्स. Kinetics of particles. It is a branch of dynamics. It is a branch of dynamics which deals the body which is the body in motion. It is the body in motion. Body in motion due to the application of forces. Due to the application of forces. Next point, Newton's second law of motion. I am jumping directly Newton's second law, okay? Because first law is not useful in this case. Just you should remember for the first point, first section point of view. Newton's second law of motion. According to Newton's second law, according to Newton's second law, the rate of change of the rate of change of momentum is directly proportional to directly proportional to impressed force and takes place in which and takes place in the direction in which the force acts, which the force acts. The force acts. Okay. So how can I write this equation? Here F is equal to what is it? According to Newton's law of motion, the rate of change of momentum is directly proportional to the impressed force, and it takes place in the direction of the in which the force is acts. Okay. The above definition, write down. The above definition leads to the statement that force is directly proportional to बोलिए to the product of mass and acceleration. So that is, how can I write this statement? F is directly proportional to m into a. So if I remove the proportional, what I will get? There is a proportionality constant k, it will come. So if I take k is equal to 1, so F is equal to k into ma, correct? If I take k is equal to 1, then can I write this equation as F is equal to m into a? Yes, this is the equation from Newton's second law, of motion. Okay. Have you written this much?
Yes, sir.
All of you.
Yes, sir.
Okay. So have you understood second law of motion? That is Newton's second law of motion. Okay. Then if you understand this second law of motion, then only you can understand the next D'Alembert's principle, or else you will not understand. Okay. It means the force is directly proportional to product of mass into acceleration. That is the Newton's second law of motion. Okay. This much you have. So next, here, how many force a body is there? In order to move this body with an acceleration A, how much is the force given? Only one F. Only one F. Okay. So next point, write down.
यहाँ पर से ठीक है
Huh?
यहाँ पर से ठीक है
Okay. Instead of a single force, yes, all of you written. Don't talk. Instead of a single force, instead of a single force, if a system of forces acts, if a system of forces acts on a particle, system of forces acts on a particle, the above statement reduces. The above statement reduces to resultant force is equal to the product of mass and acceleration, in the direction of the resultant force, resultant force that is R is equal to m into a. R is equal to m into a. R is equal to m into a, where R is resultant of forces acting on a particle. Okay. See, whatever this Newton's second law you have written, here the only single force was there. Correct? Now, if at all a body is there, okay, there is a force F1, there is a force F2, there is a force F3. Okay. So this is a force. How this body is going to move? If at all there is no F1 and F2, there is no F2 and F3, how the body is going to move? Along the line of direction of the force. Correct? All of you. Correct?
Yes, sir.
Yes. If there is no F1 and F3, then the body is going to move along the line of action of the second force. Correct? If there is no F1 and F2, how the body will move? Along the line of direction of the F3. Correct? Na? Is it correct, all of you?
Yes, sir.
Then now the force, the body particle is subjected to a more than one force. It means multiple of forces. Then how the body is going to move? It is going to move. That is the resultant of the force. You have to determine the resultant of F1, F2, and F3. So that is what he is saying. Instead of single force, if a system of forces acts on a particle, the above statement reduces to the resultant force. Correct? Then it is equal to the product of mass and acceleration in the direction of the resultant. In which direction? That is along the direction of the resultant. not the result direction of the F1 or F2 or F3. It is along the direction of the resultant. What is the direction of the resultant? Alpha. Alpha is equal to what? Tan inverse of sigma Fy upon sigma Fx. First class, first chapter. Correct na? याद आ रहा है सभी को? Yes.
Yes, sir.
So R is equal to, I am writing R is equal to F, that is F into MA. F is R is equal to M into A. What is R? R is the resultant of forces acting on a particle. Okay, then this statement can we modify? This statement instead of single statement, can I modify this statement? Yes, take it on next. Hence, next line. Okay, hence, many times, Newton's second law is stated. Newton's second law is stated as a particle acted upon by an unbalanced system system of forces has an acceleration directly proportional to and in line with the resultant force. Okay, so we can call like this also. Newton's second law of motion we can define like this also. Okay, Newton's second law of motion we can state like this also. How? It is a particle acted upon by an unbalanced system of forces. Unbalanced means R is existed, resultant is, if it is balanced, R is equal to 0. Okay, that's why I am saying unbalanced system of forces has an acceleration directly proportional to the line of unbalanced system of forces has an acceleration directly proportional and in line with the resultant force. Okay, ये सबको समझ में आ गया? Okay, if it is a single force, the direction is along the direction of the force, line of action of the force. If it is a multiple of forces, then the direction of the body or the particle is along the direction of the resultant forces. Okay, this is the multiple choice question. You may expect like this. Okay, next, D'Alembert's principle. This is important for the examination point of view. D'Alembert's principle. D'Alembert's principle. French mathematician Jean Le Ronde D'Alembert. It is the name of the scientist. D'Alembert. He is a French mathematician. D'Alembert proved in D'Alembert. Okay, write it. D'Alembert proved In 1743, in 1743, that Newton's second law, Newton's second law of motion, Newton's second law of motion is applicable, is applicable, is applicable not only to the motion of a particle, not only to the motion of particle, motion of particle, motion of particle, not only to the motion of particle, but also to the motion of the body, but also to the motion of the body, motion of the body. Thus, equation may be written as, thus equation may be written as, may be written it as R minus MA is equal to 0. This is equation number 1. R minus MA is equal to 0. The term negative MA, the term negative MA may be looked as, may be looked as a force of magnitude m into a, of magnitude m into a, of magnitude m into a, applied in the opposite direction, in the opposite direction, the opposite direction of motion, and is termed as, inertia force, or reverse effective force, reverse effective force. Reverse effective force. From equation 1, from equation 1, D'Alembert states that, system of forces acting, on moving body, in dynamic equilibrium, with the inertia force, of the body, This is known as D'Alembert's principle. This is known as D'Alembert's principle. D'Alembert's principle. Okay. As per the D'Alembert's, what he is saying, whatever I am writing here, that is R is equal to M into A. Okay, that is system of forces which are acting on a body. Okay, that R is equal to M. If you take, that is the second law of motion, Newton's second law of motion. Okay, all of you consider a little bit, that is small change is there. The French mathematician Jean de D'Alembert proved in 1743 that Newton's second law of motion is applicable not only to the motion of a particle but also to the motion of the body. Okay, thus the equation may be written as R minus Ma is equal to 0. The term negative Ma may be looked as a force of magnitude M into A applied in the opposite direction of the motion. This is very, very important. Okay, that is M into A is applied in the opposite direction of the motion and it is called as inertia force or reverse effective force. Maximum we are calling it is inertia force only. Okay, so hence from this equation number 1, D'Alembert states that the system of forces acting on a body, moving body, in equilibrium. In which type of equilibrium? Dynamic equilibrium with the inertia of the force of the body. Okay, it states that system of forces acting on a moving body in a dynamic equilibrium with the inertia force of the body. This is known as D'Alembert's principle. See, it is actually okay. So when you take R is equal to M into A, that is equation of the Newton's second law of motion. Okay, I want to write the dynamic equilibrium. So as you have seen in the static equilibrium condition, what is the static equilibrium condition? Sigma fx is equal to 0, sigma fy is equal to 0, and moment about a point is equal to 0. Similarly, I am going to write the dynamic equilibrium condition. So that dynamic equilibrium condition must be equal to 0. Okay, so this is the second law of motion. So I am writing R minus Ma is equal to 0. Means the particle, not only a particle is in under motion, the entire body is under motion. Okay, that is dynamic equilibrium I am taking. So all the term is equal to 0. What are the terms? All the terms resultant of all the forces, and again there is a negative force. What is that negative force? That is M into A. This is the negative force. That must be equal to 0. Okay, this M into A is called as what? Inertia of forces. Inertia of forces. So always this inertia forces is opposite to the direction of the motion. All of you have to remember this point. Always inertia forces must be opposite to the direction of the motion. Is it clear, all of you? Yes.
Yes.
So just underline this the point. Yes, yes, like friction, but here there is no friction right now. Okay, don't consider inertia force is opposite to the direction of motion. You write this one, underline this point. Negative term Ma is body, it is opposite, applied in the opposite direction to the motion, and hence it is termed as inertia force. Okay, okay, you have to write this point. आपको ये समझ में आना पहले. Is it clear? D'Alembert principle. What is the D'Alembert principle? It states that system of forces acting on a body in dynamic equilibrium with the inertia of the force of the body. Okay, this is important. Inertia of the force. That is very, very important. Okay. So what is dynamic equilibrium? Write that one point about the dynamic equilibrium. Dynamic equilibrium. Dynamic equilibrium. According to Newton's law, right on. We are dealing only about the second law only, not about the first or third law. Okay. According to Newton's law, body moves in a straight line. Body moves in a straight line in a straight line, in a straight line to a certain acceleration, to a certain acceleration, to a certain acceleration due to the effect of forces, due to the effect of forces. Are you getting? We are considering all the forces and also mass. Okay, in the D elements principle, there is a mass term. Okay, R is due to what? Resultant of forces. We are considering the motion of the body along the, what are the reason for the motion? That is force and mass we are considering. So that's why this comes under the kinetics part. Okay. So a certain of the certain acceleration due to the effect of force, effect of applied force, effect of applied force, effect of applied force, applied force. So this body can't be in equilibrium. So this body can't be in equilibrium. Because presence of presence of applied force and equation of statics and equation of static equilibrium are useful or not useful? Equation of static equilibrium are useful or not useful? Useful. Either useful hota hai kya? When the body is under is okay motion, how it is useful? Equation of static equilibrium are not applicable. Are not applicable. Not applicable. If now an imaginary force, imaginary force is applied to the body, opposite to the direction, opposite to the direction of acceleration, then resultant force, acting on body becomes zero, and hence body brought to equilibrium condition, but it is still in accelerated motion, then body is said to be in dynamic equilibrium. In dynamic equilibrium. Okay, concentrate what I am saying. So according to the Newton's second law of motion, the body moves in a straight line, correct? To a certain acceleration due to the effect of the applied force. But so this body cannot be in equilibrium. Whenever the body is there, the force is acting, it is under motion. Is it in equilibrium? No, it is not in equilibrium. But the body is not, it can't be in equilibrium because of the presence of the applied force, and equation of statics are not applicable. Correct? Then if now imagine an imaginary force is applied to the body opposite to the direction of the acceleration, then resultant force acting on the body becomes zero, and hence the body brought to the equilibrium condition, but it is still under accelerated motion. The body is said to be equilibrium, dynamic equilibrium. So think that there is a body, okay, you are giving a system of forces, it is under motion only, okay. So this is F1 F2 F2, so okay, this is under motion. So think that इसका resultant क्या है? Resultant आ रहा है. Think there is a resultant force is given opposite to this one, that is inertia force is giving. It means this minus this must be equal to 0, but the body is under motion only, body is under motion, but the because of this R and because of this inertia force, the body is under equilibrium. Hence we can say that it is dynamic equilibrium. We are not applying static equilibrium condition. The body is not in under static, it is in dynamic, it is in motion, but it is in dynamic motion. Okay, is it clear everyone? All of
Yes,
you?
sir.
Yes, sir.
Yes, you just try to imagine, you just understand करने का. इसके लिए मैंने dictate कर रहे हैं, नहीं तो PPT में just slide दे रहे हैं, but that is not important. Okay, you have to understand this point. Okay, so wait. Okay, I will give one small problem. You will solve this one. Motion of a lift. Okay, take down. Take. Okay, before solving this problem, projectile का एक problem देने वाला है. Okay, read on that problem. Projectile का एक problem case छोड़ा था ना, उसमें लिखिए अलग projectile का. Question number कितना 3 है क्या? Second, third है, third or fourth? Oh.
Third.
All of you read on the projectile का problem, homework problem. A soldier fires a bullet with velocity of 31.32 meter per second at an angle of alpha, upwards from horizontal from his position on a hill to strike a target which is 100 meter away, and 50 meter below his position, find the angle of projection alpha. Also find velocity with which velocity with which bullet strikes the object. Bullet strikes the object. This is the ground. This is the bullet is striking here. This is alpha value you have to determine. So he has given initial velocity u is equal to upwards within 31.32 meter per second. 31.32 meter per second. From the his position on a hill to strike a target which is 100 meter away from him. What is this 100 meter away from him means? Yes. Is it a range or height? Yes. Horizontal range he has given. Okay. So A to D it is given. Then one more is given. 50 meter high means what? What is this? 100 meter away, 50 meter below the position means that is. Okay, the ground level say that correct? Yes. So this one is 100 meter, and this one is 50 meter. 50 meter. So what is asked? You have to determine the value of alpha first, and also you have to determine find the velocity with which the bullet is striking. Means final velocity here the bullet is striking. So उसमें find out करना है तो क्या find out करने का? Initial vertical velocity find out करने का, then vertical velocity, downward velocity, then horizontal velocity. Resultant of those two will be equal to your final velocity. Correct? So first, how to find out the value of alpha? You know equation of the projectile. Okay. So given what are the given points? What are the given points? U is given. U is equal to 31.32 meter per second. Then he has given x coordinate. What is total x? That is 100 meter. Okay. Then what is the y coordinate? 50. Is it positive or negative? It is downward coming. Okay. We have to take it is minus 50 meter. Then from the equation of the projectile. Equation of projectile. What is the equation of projectile? Yes, tell me. Y is equal to x. Yes, you have to remind. Yes, all of you online. X tan alpha minus g x square divided by 2 u square. Cos square alpha भी लिख सकते नहीं तो 1 plus tan square alpha. Am I audible? All of you. एक ही क्वेश्चन. Okay, इसमें what is known, what is unknown? Yes, all of you. Y is known. What is the value of y? Minus 50. What is the value of x? 100. Wait. What will you have? Okay. What is tan alpha? Tan of alpha कितना है? Alpha is unknown. Then minus g is 9.81. Then x is equal to 100 square divided by 2 times of initial velocity is given 31.32 square. Then 1 plus tan square alpha. Okay. Now calculate the alpha. Homework का ही बोल रहे हैं ना? Now ये homework का ही करिए. Just calculate all of it. हाँ अभी कैलकुलेट करो. रेडन फर्स्ट. ये रेडन करो, सॉल्व करो. मुझे बोलिए कितना है. तब तक मैंने अटेंडेंस ले. Yes, all of you calculate the value. Roll number 6. Roll number 6. Mentor session. कब है? आया क्या? ओपन करो. ओपन करो. Roll number 6 absent. 10. 9 present. 10 present. 11. 13. ओके कैलकुलेट करो. हाँ नो रॉन्ग. सॉल्व करो स्टेप बाय स्टेप सॉल्व करो. डायरेक्ट सॉल्व मत करो. Roll number 13 absent. 14 present. 15 16 17 20 G 20 present. 34 52 53 61 64. Okay, absent numbers 6 13 16 17 53 64. These are absent numbers. Yes, solve नहीं किया. 100 tan alpha as it is. So minus 50 as it is. 100 tan alpha as it is. Only A solve करो. 9.81 into 100 square divided by 2 into 31.32 square. कितना था देखो? 50. Yes, minus 50. Correct. Minus 50 into 1 plus tan square alpha. Correct. Yes. Open that bracket. 100 into tan alpha minus 50 tan square alpha. Correct. This is equal to minus 50. This minus 50 get cancelled. Then so can I write this equation as 50 tan square alpha? Correct. So can I take tan alpha 50 tan alpha outside?
Yes, sir.
Okay, what is remaining? Tan alpha is remaining. Then minus 2 is remaining. So okay, you are not getting. Okay, wait. I will explain. Tan square alpha minus tan square alpha I will take to the left hand side. Plus tan square alpha I will take this 100 to other side. That is 100 minus 100 tan alpha. नहीं तो ऐसे भी लिख सकते. Is equal to 100 tan alpha. 100 tan alpha. Okay. So 1 tan square and tan get cancelled. 51 are 52 are. So tan alpha is equal to 2. Correct answer. Then can you tell me the value of alpha?
63.435.
इतना इजी है ना, फिर भी आप सॉल्व नहीं कर रहे. 63.43. Yes, 63.43. तो वो भैया कितना टाइम लगेगा इसको? 63.43 is answer. Correct. How to find? Okay, लिखा है ना? All of you done this first. How to find out the striking velocity? So first you have to determine the horizontal component velocity of the horizontal component velocity, then vertical component velocity. Have you written this much, all of you? Yes.
Yes, sir.
Okay. Can I solve next horizontal component velocity? Yes. How
Yes,
to
sir.
solve the horizontal component velocity? Horizontal component velocity. Yes. Horizontal component velocity. What is the formula horizontal component velocity? U cos alpha. Correct? U is known. How much it is? 31.32. Cos alpha is how much you have got? 63.43. 63.43. Let's calculate. 14.0. 14.0 meter per second. Then vertical component velocity. Vertical component velocity. So that is equal to, you are using the formula S is equal to ut plus half at square. Correct? So S is equal to ut plus half at square. Correct? So S is moving downward. Okay, that is minus 50. Correct? Then this is equal to, no, yes, don't take this one. So velocity I want. Okay. So in the upward direction, what is your velocity component? U sin alpha. Then while coming back, minus g into t. Correct? G into t. So what is g into t? U is 31.32. Sin 63.43 minus 9.81 into time. T is equal to how much t? 5.83. You have to determine t first. 5 point. Okay, you have to determine this one. 5.83. Okay, that you have to determine. So that is from the equation S is equal to ut plus half at square. U S is known. 50 is known. U in the vertical direction. How much you will get? 31.32. Vertical direction. 31.32. That is U 31.32 into time t is unknown. In the opposite direction, minus 9.81 divided by 2 t square. So you get a t here. T is equal to 5.83 seconds. 5.83 seconds. Okay, this t value is substituted here. Then you will get a value. Velocity is equal to just how much it is? Downward velocity minus 29.1. 29.1 into minus 9.83 into 5 sub kiya.
Minus 29.18.
21 or 37.
29.
I got it is 37.18. Okay, so again you have to determine resultant velocity.
Minus 30 आ रहा है.
30 आ रहा है क्या?
Minus 29.18.
29.18. Okay, nearly minus 30 आ रहा है. Okay. I will check. Okay, I will check. So resultant velocity is equal to, okay, if you take this is horizontal is Vx, this is Vy, then you have to calculate resultant velocity Vr is equal to under root of Vx square plus Vy square. Okay, so this is your final answer. Final answer is 40 meter per second I have got. So you just check it. Okay, I will also check this. Is it okay, all of you? So this is horizontal component, this is vertical component. In order to calculate the vertical, you should calculate t value. First calculate the t, substitute, and nice. So this completes the first chapter, that is chapter number 5, and we have started with this chapter. Have you taken? Take down the screenshot. I will stop now. Okay. Thank you all.